Hey everyone, in today's video we are going to talk about Apache Pig and Pig Latin, two powerful tools in the world of big data analytics. My name is Nakya Khurelwala and by the end of this video you will not only know what Pig is, but also how it works behind the scenes and what makes it special, and how it compares with other big data tools like Hive and MapReduce. So let's get started. Before jumping into Pig, let's understand the world it lives in. Big data. We are surrounded by data from social media posts, online transactions to sensor readings. But this data isn't small, it's massive, messy, and keeps coming non-stop. That's what we call big data. Extremely large and complex data sets that traditional databases like MySQL or SQL servers just can't handle efficiently. Big data is often defined by the 5 Bs: volume, think about terabytes or even petabytes of data; velocity, data coming in at crazy speed like tweets every seconds or live sensor data; variety, text, image, video, logs, all different formats; veracity, not all data is clean or reliable; and value, the actual insight we can extract from it. And here's the problem. Traditional database fail when the size, speed, or variety of data explodes. That's where big data frameworks like Hadoop, Pig, Hive, and Spark come into play. They are built to handle huge datasets efficiently across clusters of machines. And amongst these, Apache Pig stands out as one of the simplest yet most powerful data processing tools. So, what exactly is Apache Pig? In simple terms, Pig is like a translator between you and Hadoop. Normally, if you want to process big data on Hadoop, you'd have to write long, complex Java MapReduce programs. Pig solves that headache. It gives you a high level scripting language called Pig Latin, where you can describe data transformation in simple steps, and Pig automatically converts those into MapReduce jobs behind the scenes. It was actually developed by Yahoo to make Hadoop easier to use and later became open source under the Apache Foundation. You can use Pig for things like cleaning messy data, transforming formats, or preparing massive datasets for analysis. Basically, anything that involves moving, reshaping data on large scale. So why use Pig when you already have other big data tools? With the help of Pig, you don't have to deal with Java. Pig Latin is simple and readable. It handles any data, structured, semi-structured, or completely unstructured. Pig can deal with all. And its UDF support, if built-in functions aren't enough, you can write your own user-defined function in Java or Python. And Pig automatically optimizes your code before execution. And its parallel processing, it divides the data and processes it in parallel across Hadoop nodes, which means speed. And it is easy to use. It is beginner friendly for data engineers who just want to get their work done. So Pig is basically like a smart assistant that simplifies heavy big data work. Alright, now let's look at how Pig actually works behind the scenes. This diagram explains the flow perfectly. Imagine you have written a Pig Latin script. Here's what happens step by step. First, the Pig Latin script. This is your code. It defines how data is loaded, transformed, and stored. Then comes the parser. Pig first checks the syntax and semantics. Basically, it ensures that your script is valid and creates a logical plan. Then comes the optimization. Pig looks at your plan and rearranges or merges operation to make it faster. Then the optimized plan is then converted into a physical plan, which means that it's now a set of actual map reduced jobs. Then the execution engine, these jobs are then sent to Hadoop clusters for execution, distributed across the nodes running in parallel. Then Hadoop Distributed File System, that is HDFS. Finally, Pig interacts with the HDFS for reading inputs and saving outputs. So from a single Pig script, Pig goes through these 6 layers and ends up executing complex MapReduce logic automatically. That's what makes it so powerful. Now this table here compares Pig, Hive, and MapReduce. Think of it as different ways to talk about Hadoop. MapReduce is low level, it's pure Java code, great for developers but very technical. Then Hive. Hive is high level, it uses HiveQL, which looks like SQL, great for analysts. Pig sits right in the middle. It uses Pig Latin, a scripting language that gives more control than SQL but less complexity than Java. So if you're a data engineer building pipelines, Pig is your go-to. Hive is for reporting and analytics. MapReduce is for custom algorithms and deep control. Together, they complete the big data ecosystem. Now let's dive into the language itself, Pig Latin. Pig Latin is like SQL but procedural. Instead of just saying what you want, you also describe how to get it. You can use it to load, transform, and store data without touching Java or MapReduce. It supports operations like filtering, joining, grouping, sorting, basically everything you need in data preprocessing. It runs in two modes: local mode for small data or testing on your personal machine, and MapReduce mode for full-scale big data on Hadoop clusters. In short, Piglatin gives you a smooth step-by-step way to handle big datasets easily. Let's talk about how Pig stores data and organizes it. This diagram here shows the data model. At the smallest level, you have a field, that is one piece of data, like name or age. A collection of field forms a tuple, kind of like one row in a database, and a collection of tuples form a bag, which is like a whole table. Pig also has maps which can store key value pairs. For example, city Mumbai, state Maharashtra. And the best part, these can be nested. You can have a bag of tuple inside a map. That's something traditional SQL tables can't handle easily. This flexibility allows Pig to process JSON files, XML data, or log, which are very common in real world. Now, on this slide, you can see a table listing all the data types Pig supports. There are three main categories. First is the primitive type: int, long, float, double, char array, and byte array. Then the complex types: tuple, bags, and maps. These hold structured or grouped data. Then nested type: combinations like bags of tuples with maps inside them. This variety is what makes Pig suitable for messy real-world data that doesn't fit neatly into rows and columns. Now, this is where Piglatin really shines. Its operations. Look at this table. It lists the most common ones: load and store for reading and writing data from HDFS, filter for removing records you don't need, for each generate to transform your data, group and join for combining or grouping datasets, order for sorting, and distinct to remove duplicates, limit for controlling the number of records. These operations can be chained together, so you can build an entire data pipeline step by step. That's why people call Pig a data flow language rather than a query language. Now, let's see how Pig is used in real world analytics. ETL operations, that means extract, transform, load, cleaning raw data before loading into warehouses. Log analysis, used by companies like Yahoo or LinkedIn to analyze click streams and server logs. Data aggregation for BI, summarizing sales, performance, or customer behavior. Machine learning preparation, preparing massive datasets before model training. Social media analysis, dealing with unstructured posts and comments. And now the advantages. It is a high level abstraction, so no messy Java code. Easy and readable. Faster development scripts are up to 20 times shorter than MapReduce. Extensible through UDFs. Scalable. Handles terabytes easily and runs on MapReduce or Spark Engine. Basically, Pig simplifies big data work and saves tons of time. This slide is interesting because it clears one common confusion. People often think Pig Latin is just like SQL, but they are fundamentally different. Pig Latin is procedural. You describe how the data should flow step by step. SQL is declarative. You only describe the final result you want. SQL works on relational database with fixed schema, while Pig can work with semi-structured data like JSON, logs, or XML. SQL runs directly on database engine. Pig scripts get converted into Hadoop jobs. So, if your use case is real-time queries and reports, go with SQL or Hive. But if you are handling huge data transformations or ETL, Pig is way more flexible. Of course, no tool is perfect, and Pig has its limitations. First, it is not SQL standard, so it has a smaller user base. It runs on top of MapReduce, so for small data, it is way slower. Optimization is limited compared to modern engines. Advanced analytics like ranking or window functions aren't built in. No transaction support, therefore no real-time updates or rollbacks. It is deeply dependent on Hadoop, can't work standalone, and it is mainly for batch processing, not live streaming. So if you need real-time analytics, use Spark or Flink instead. But for heavy ETL and large-scale preprocessing, Pig is still a strong choice. Now let's talk about some built-in functions. You'll use these a lot. There are string functions like concat, substring, trim, upper, replace for text processing. Mathematical functions like absolute, round, square root, log, power for numerical work, and aggregate functions like count, sum, average, minimum, maximum for analytics. And finally, user-defined function, UDFs. You can load your own Java or Python jar files and extend Pig's functionality, and then use your own custom function in scripts. That's what makes Pig powerful. You can make it your own. So that's it. So to quickly wrap up, Apache Pig makes big data processing simpler, faster, and more readable. Pig Latin bridges the gap between coding and SQL by giving you a procedural yet flexible way to manipulate huge datasets. It is perfect for ETL, data transformation, and pre-processing in Hadoop environments. I hope you found this explanation helpful. Thank you so much.